All right, kids, thanks for joining me today. There's going to be some mistakes today as I do this, but just hang with me. I'm going to be talking about the greenhouse effect. And when we start that, we have to start by talking about the sun, because that's where all energy on the earth comes from. The sun's energy is something called solar radiation. Now, I'm going to geek out a little bit on this, so take it as it is. Solar radiation is kind of interesting because it comes as something called short waves. So there's different sizes of waves when it comes to energy, and this is true for all forms of energy or most forms of energy. But solar radiation is really short waves. And this is important because it's one of the things that allows the sun energy to get past our ozone layer and get absorbed by the earth. Infrared radiation is a different type of radiation that's going to be important for us later in a little bit. And infrared radiation is long waves. So just keep that in mind. So solar radiation is short, so solar short, and infrared radiation is long. So the sun sends its rays throughout our solar system, and many of those hit the earth. When they do, 48% of the solar rays are absorbed at the surface. That means the surface of the earth literally absorbs that radiation. 23% is absorbed by the particles in the atmosphere. And 29% is reflected. And this is important because that's one of the reasons we have the ozone. The ozone is a layer of specialized gas that helps reflect some of that sun's energy, which is important because it keeps the earth from heating up too much. But the part we really want to focus on is that 48% that gets absorbed by the surface of the earth. And we'll come to that in a minute, but let's take a look at the reflection side of things. So there's this thing called the albedo effect. So the albedo effect is the idea that everything on Earth absorbs and reflects solar radiation differently. And this is actually something you inherently know, but we don't talk about this in normal society. So fresh snow actually reflects 80 to 90% of the sun's energy. Forest only reflects 10 to 20%. You're probably like, well, why is that the case? If you think about it, on a really sunny day when you walk outside and there's a fresh layer of snow, it's almost blinding because the sun's energy is getting reflected back into your face. Think about cars. I did a little research just for fun of it, and I found out that the most popular car or color of car in Texas and Florida is white, but in Michigan and Maine, it's black. And that comes back to the albedo effect because white, lighter colors reflect the sun's energy, and black absorbs the sun's energy. So that's why you see a lot of white colors in some of the more popular areas of the world. Even down in Florida, where it's fairly hot, some of them will paint the top of their roofs. They've got those orange clay roofs, and they'll paint them white to reflect the sunlight. It will keep the house cooler. So, what does all this mean? Okay, well, if we look about the Earth, take a look at the albedo effect. The albedo effect is gauged by a number 0 through 1, 1 being a high reflection, the highest you can get, and 0 being the highest absorption. And if you look throughout the world, you can see up north where we've got a lot of the icy areas like in Siberia and Alaska and stuff, you see a lot of reflection going on there. And that's one of the reasons the polar ice caps are so important because they reflect a lot of the sun's light, helping the earth stay cool. But you also see the desert of Africa. And that's true too, because the Sahara Desert reflects a lot of light because it's kind of this light tan color. Interior of Australia, the same way. So definitely the deserts of the world and the ice caps of the world too. Now you may be wondering, like, hey, look at the southern part of the hemisphere. What's going on down there at the very bottom? But as it says, this does not include anything in white. Like they didn't take the albedo effect into consideration for the oceans or for the anything in white. So FYI. All right, so let's put this all together. So what's going on? Well, one, we know that solar radiation is being sent to the Earth in short waves. Some of that solar radiation, a good portion of it, is getting reflected back, like it's getting returned back into the Earth. And let me just jump back to that screen real quick to remind you, 29% of it is getting reflected. 23 gets into the atmosphere, but 48% gets to the actual surface of the Earth. Some of it is absorbed, some of it is reflected again. But this is where the gases come into effect, because as that energy is absorbed and reflected, it's reflected as a different type of energy called infrared. Huh. So let me go back to a earlier screen. Do you remember this? Infrared radiation is different than solar radiation. It's long waves, it's not short waves. So as that solar radiation gets in, because it's short waves, it passes through our atmosphere, gets absorbed by the Earth, but when the Earth emits it again and releases it, it comes back as long waves. And that's a problem, because carbon dioxide, nitrous oxide, chlorofluorocarbons, all of the greenhouse gases will reflect long waves. So most gases in the atmosphere do not absorb long wave radiation. But carbon dioxide, water vapor, nitrous gases, methane, they like to absorb them and keep them around, okay? And that's really where the problem is, because as those long waves are emitted from the Earth, all our greenhouse gases collect them and store them and absorb them. Now let's give a practical application of this. I always need to have something that I can like tangibly see and understand. So let's take a look at a car. And I talked a little bit about this yesterday. All right. So we all have cars, and I told you the story about how like my cell phone got overheated because it was sitting on the dashboard of my car, and I thought that was kind of strange because it actually wasn't really hot outside, but inside my car it was really hot. Luckily, it wasn't my wife's because she has like darker seats than mine. But what happens throughout the day is the solar radiation, which is in a short wavelength, comes through your car window, and it can easily pass the car window because the car window is kind of like the atmosphere or ozone layer of our Earth. Short wavelengths can get through it. But once it gets in there, it gets absorbed by the seat and the dashboard and the carpet and all the parts of the car. And when the parts of the car emit or release that energy back into the atmosphere of your car, they release it as infrared radiation, which is long waves. And guess what? Long waves cannot get out of the glass very well of your car. So those long waves hit the glass and bounce back. And so you have this occurrence of the greenhouse effect inside your car where those waves are bouncing back and forth, and the car's internal heat is just increasing and increasing because all that sunlight just keeps getting into the car and getting trapped there. This is exactly what's going on with the greenhouse effect. And I got a kind of a cool animation I want to show you. Here we have the sunlight reaches the Earth, it's absorbed, energy is reflected, some escapes, but some is absorbed and radiated as heat inside the internal parts of Earth because the greenhouse gases catch those long waves and absorb them. So this is a good thing. Like, having greenhouse gases is not a bad thing, but it can become a bad thing when we have too much of them, because then the temperature of the Earth can't cool itself as quickly as it's gaining the heat. So the internal temperature of the Earth, or the atmosphere of the Earth, begins to heat up. Think of it like this, and I've said this before. It's great to have a coat, but if the coat gets too thick for the temperature outside, you're going to get overheated, and nobody likes that. So let's look at today's notes and what we need to write down. Here are the specifics, things that you need to know and remember. 1. Solar radiation is either absorbed or reflected, and I've kept the percentages a little bit simpler for you. 30% in general is reflected into space, with 70% being absorbed by the Earth. The energy that is absorbed, and if you look down here, let me bring my little cursor over here, okay? So 70% gets in through the atmosphere, 30% is reflected, okay? And that 70%, some is absorbed by the atmosphere inside the Earth's surface, and some actually gets into the Earth, okay? So then in step 2, we have infrared radiation is released from the Earth. So that radiation from the sun that's absorbed from the Earth is then released back. But when it's released back as long waves, which don't get through our atmospheres easily, okay? Because those long waves get caught up from the greenhouse gases. Some of them do get out, about 12%, as you can see from the picture, about 12% right here get released and escape out of the atmosphere. But then the rest of it is all captured by these greenhouse gases in our atmosphere. And they begin to bounce back and forth trapped inside of our atmosphere. Again, some of it will escape over time, as you see, but those greenhouse gases are what trap it. And again, it's a good thing, except now we're having the problem that because humans have created so much more greenhouse gases, we're just trapping more and more of that long radiation, that infrared radiation, those long waves. And that's heating up the planet. Now, what does this mean? Well, as the planet heats up, our polar ice caps that we've talked about begin to melt because we have less polar ice caps. Going back to a previous slide, we're going to be able to reflect less of the sun's energy, which means more is going to get absorbed into the atmosphere and absorbed by those greenhouse gases, which is going to cause the Earth's temperature to increase, which will cause more of the polar ice caps to melt, and so on, and so on, and so on. So that's really what we're talking about when we're looking at this whole thing. What's the problem? The greenhouse gases aren't the problem. The problem is that we are making too much of the greenhouse gases. Kind of like wearing a coat, too thick of a coat for the temperature outside. We're trapping too much of the sun's energy to the surface of the earth, and that's increasing the global climate and the temperature that it is. Now, this increase is not drastic. It's not like each year we're raising 10 degrees. It's very small. But the fear is as that increases, this effect will start to move quicker, and that will cause changes on our Earth that we have to adapt and change to meet. So here's the point. It's not that change isn't going to happen on the Earth. It's that because we're creating these excess greenhouse gases, the Earth's changes will happen too quickly for humans to adapt to and for the Earth to adapt to. Because remember, adaptation takes a long time to take place. So what we need to do, the thought is reduce the greenhouse gases so that as the Earth heats up, which is a natural thing over time, it goes through phases, that we will have time to adapt our way of living and the Earth will have time to adapt its way of living to adjust to the new temperature of the Earth. All right. Hopefully I didn't talk too long. Thanks for watching this. Make sure you get your notes finished and then complete the rest of the assignments for today. And thanks so much for being such a great class. I really appreciate you.